right, welcome to Hot Topics again. This is our only topic in Chapter 5, but we realize this is one of the most difficult topics in the whole course, and that is because it involves what, Bill?
Fractions, one of those big F words. Yeah, this is adding and subtracting rational expressions, which really just means adding and subtracting algebraic fractions.
That's it. So let's see if we can simplify this for you. First of all, you probably remember from your days way back when you started learning this stuff that in order to add fractions, you need common denominators. That's really the hardest part here. Once you determine the common denominator, then you rewrite the numerators and then add or subtract the fractions. So when I look at this is a monomial and this is a monomial, and I ask myself, okay, what is the least common multiple or the least common denominator between 5 and x? And simply put, it is 5x in this problem. So when you change a denominator, remember you now have to change your numerator. You can't just carry down the numerators 3 and x once you've changed their denominators. So in this denominator, I went from an x to a 5x. So in essence, I hate to use this term adding, but I added a 5 to the denominator. You know it's multiplied. I've added a new term of 5. So that 5 I now have to multiply by the 3. Same case goes over here. I went from a 5 to a 5x. So I added an x. That means I have to add an x to the numerator. But again, adding, bad word, but we're going to multiply all these when it's all said and done.
Essentially, what Jerry's saying is to go from 3 over x, he's going to multiply the top and the bottom by 5. And in the x over 5, he's going to multiply the top and the bottom by x because he wants to make the denominators the same. He wants them both to be 5x.
Okay, so now here's our new numerators. 3 times 5 is 15. X times x is x squared. Now I can add them, or at least we use the term add them because, Bill, we really can't add these.
Right, yeah, but we can combine them and at least put them over a single denominator, which is what we want to do.
That's it. So our final answer is 15 plus x squared, or probably more proper to write x squared plus 15 over 5x.
Now, don't cancel those x's because you can't. Don't go from the right answer to the wrong answer. You cannot cancel when you're adding and subtracting. You can only cancel things that are being multiplied together. And the 15 and the x squared are being added. So you can't cancel the x in the bottom with the x squared in the top. And that's a really common mistake that we'll see.
Absolutely. And just for the same principle here, the 5s, don't
yes,
cancel 5
you can't cancel the 5 and
15.
15 either. That would also be a disaster, so don't do it. Again, this often doesn't look to students like this is the answer because it seems sort of messy, but it is. That's all you can do with this problem.
That's it. All right, in our second one, we now have a monomial underneath the 7 and a binomial underneath the x. Now, the good part is if you recognize that, the least common multiple or the common denominator here is just the 2 combined. That's it. So we have x times x plus 2.
And go ahead and leave that factored. You're not expected to multiply it out.
That's a good point. Okay, now, in this problem, the 7 was over x, now it's over x plus 2. So I added that x plus 2 to the denominator, so I'm going to have to multiply the top 7 by x plus 2. Over here I went from this and I added an x, so that x is going to have to be multiplied by the x in the numerator. So here's my new problem. Now, distribute out, probably the most common mistake. Students think, oh, I just multiply by the x. No, it's the whole term. So you end up with 7x plus 14 in that numerator. Then over here you get x squared. X times x is x squared. Now, make sure you watch your signs. That is minus x squared. So our final answer, and to write this in proper order, we should probably put the negative x squared first, then the 7x, then the 14, because you can't add a single thing together. There's not a like term. There's not a single like term.
Yeah, there are no like terms in this one, yeah.
And then the denominator is just the x times x plus 2. That is your final answer for that one. All right, these next two, again, appear to be just like the last problem, but you'll notice here in a second it is a lot more complicated. Start out, the common denominator is pretty simple. You have a monomial, binomial again, so the common denominator is both of them combined. There is no relationship between the monomials and the binomials. Now, we ask ourselves, what did we go from here to here? Well, we added that x. So that x is going to get multiplied in the top. And then what I add down here, well, I added x plus 2. And that's where this problem gets interesting. Because that is a binomial here, and my advice is you better put that in parentheses because you're going to have to FOIL or multiply or whatever that entire numerator before you can go any further. So here's my new numerators. Over here, negative 8x, not a problem. Over here, when you FOIL, and I'll do this over here on the side just so you see it all worked out. There's your 2x squared plus 4x plus 1x plus 2, which gives us 2x squared plus 5x plus 2. That is what I'm going to write over here. Okay, now we can finally combine some like terms.
Finally.
All right, so our final answer, you can write your denominator first. Your numerator, you can combine the negative 8x and the 5x. But again, put it in descending order. So we're going to start with 2x squared. Negative 8 plus 5 is negative 3. And then the plus 2. And that is it. That is your final answer.
Now, if you're looking at that and thinking to yourself, what if that factors? If you check it, you'll see you need numbers that multiply to 4, but you'd also need them to add 3, and there are no numbers that multiply to 4 and add to 3. So you can't factor that, and so nothing could cancel, so that's the answer.
Yes, now if you could have factored it, definitely try it and double check.
Right, because sometimes something in the top will cancel with the bottom. But the secret is it's kind of hard to rig these problems so that things cancel, so a lot of times things won't.
Yeah. Okay, let's look at one more of these. This one involves 3 terms, and we know you see this in ALEC, so this is as challenging as it gets. Now, we have a monomial and a monomial. So now we look at the terms, we start with the numbers. Think of the least common denominator or the least common multiple between 9 and 6. And in this case,
chances are you'll think that would probably be 18. So again, you think to yourself, let's see, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 9 also goes into 18. That's a good number to use.
Yeah, so 18, and then we just use the x because they are the same. So that works.
All right, so we want to have this time, since there's 3 fractions, we're going to end up with 3 fractions, all of which have the same denominator, 18x.
That's it, because 2 has an imaginary denominator 1, which
right.
has no impact on your denominator there. So now we've got to rewrite all these numerators. This one, now we're thinking more or less division. We didn't just add something. Using the term adding 9 here, that would not be appropriate. And that's why I really hate to use the terminology.
Right. The question you really ask yourself is, what did I do to 9x to get 18x? To get an 18x, I multiplied 9x by 2, so I also have to multiply the top by 2.
That's it.
And for the second one, what did I multiply 6x by to get 18x? Well, to do that, I multiplied it by 3, so I also have to multiply the top by 3. And finally, to change 1 to 18x, I'd have to multiply 1 by 18x, so I have to multiply that by 18x. And again, at this point, the worst of it's over. The rest of it is just multiplying and combining like terms.
Yes. So here's our new numerator here. Distributing out the 2, you get 2x minus 2u. The second part, you distribute out the 3. So 15x plus 12u. And then the last one, 18x times 2, 36x.
Now, if you've gotten this far correctly, be very careful. The next step is going to be distributing that minus sign. And this is the place, as Jerry was mentioning earlier, where we'll see a lot of mistakes. So be very careful in these last steps.
Yes, if you recall way back in elementary algebra, when you minus a polynomial, you actually change the signs on both terms. So we want negative 15x minus 12u. That's what those terms actually are. Now we can combine like terms. So we have a 2x, take away 15x is negative 13, and then negative 13 plus 36 is?
23, I think.
23x. And then we look at our u's. We have a negative 2u and a negative 12u is negative 14u. And that is all over 18x. x.
Again, a really messy answer, but these are what the problems in ALEKS look like. So if you see a problem like this and get an answer like that, chances are it's right.
Yes, now if you want more practice on this, because that is it for that one, look on pages 190 to 193 in your textbook. We've got several examples written out. Start step by step, and hopefully this helped you out.
All right, and we'll see you in the Hot Topics for Chapter 6.